4.1 radian measures in degrees. We reviewed our geometry stuff last week, and now we're going to get into our radian measure. Make this bigger for us. It's just going to be like that, evidently. Okay, our learning goal is to convert between radians and degrees, as well as knowing different things about angles. Okay, so first thing we need to know that an angle has an initial side and a terminal side. What's actually happening is this initial side shows the starting position of the ray, and then it moves. So you have both a starting and an ending position, thus the word terminal, like in terminate. So you have an initial side and a terminal side, and you'll usually hear me say ray instead of side, but it's the same thing. Okay, the end point of a ray is the vertex. The end point of the ray is the vertex of the angle. You should already know that. Standard position puts the vertex at the origin, so at 0, 0, has the initial ray or side on the positive x-axis, and then it moves from there. That is an angle in standard position. If it is in standard position, the vertex is on the origin again, and its initial ray is on the positive x-axis, and its terminal ray can terminate wherever it terminates at. Positive angles go counterclockwise. They rise. That's how I like to think about it. The terminal ray rises. Negative is clockwise. It falls. So we'll have negative and positive angles. Another thing that you need to be aware of is angles are labeled in Greek letters, alpha, beta, theta, as well as uppercase letters A, B, and C. We use mostly theta, but we can use beta and alpha when we need. Co-terminal angles, this is one that was in your assignment, and I thought the videos covered it. Co-terminal, they share a terminal side, so that's the big, they have the same I don't know what this is. They have the same terminal side. So if you notice on these pictures, when I do a positive rotation and I do a negative rotation, they both share the terminal side. So those angles would be coterminal to each other. If you notice, that makes a whole 360-degree angle, but one is positive and one is negative there. This one as well, it starts off positive. It actually goes over one whole rotation, which is fine, and terminates. And then we have this one that just terminates here, and they are still terminal. They're coterminal angles because they share terminal rays. So, okay, radian measure. Radian measure is something they discussed in the films. So 1 radian is the length of the radius on the circumference of a circle. So if you took a piece of string and measured your radius with your piece of string, you can lay it on the circumference of the circle, right here, and that is 1 radian. It's 1 radian. The radian is the length of the radius on the circumference of the circle. And it is another measurement to for angles, not just degrees. 1 radian is the measure of the central angle theta that intersects an arc S equal length to the radius of the circle. So 1 length of the radius on the circumference of the circle. And it says theta being that central angle. The central angle is right here with the origin. Central angle equals S, which stands for arc length, and R, which stands for radius. So in our circle, we have a radius r, and we have an arc length s. Because the unit of measure for s and r are the same, the ratio of s to r has no units. And I will encourage you not to write it like this, but to s over r. They have no units because the units would reduce out, and it is a real number as well. Okay, there are, in every circle, no matter how big, how small, there are 2 pi radian in each, which is approximately 6.28 if I were to multiply 2 times 3.14. In every circle, no matter what. Because the unit of measure s and r are the same, again, the ratio has no units, a real number. Just pointing that out. Because the measure of an angle of one full rotation, the circumference of a circle is 2 pi r. So this is where we get 2 pi r is the circumference of any circle. So that would be equal to s over r. Divided both by r. So there are 2 pi radians in every circle in one rotation. So in one complete rotation, there are 2 pi radians. Therefore, if there are 2 pi radians, let me get us a coordinate plane so we can see it. If there are 2 pi radians, if I go all the way around, this is 2 pi. Well, half of that would be 2 pi divided by 2, so that would be pi. A quarter of that, which would be right here, which would be pi over 2. If I wanted a sixth of a rotation, it would be pi over 3, and so on. It all comes down with fractions and dividing it by the parts you want. And we'll talk about more of this as we go. These are common angles. We will be working with pi over 6, pi over 4, pi over 3, pi, 2 pi, pi over 2, 11 pi over 2. 11, I can't even think. 11 pi over 6. All of those more, but these are common ones that we have. And if you notice, this is pi here. So if you divide it into 6 parts, the top of the circle into 6 parts, you get pi over 6. So I refer to it as in terms of how many times it goes into pi. So we'll do more with that. Quadrants, we label quadrants counterclockwise. So we have quadrant 1, 2, 3, 4. We label them with Roman numerals. 0 to pi over 2. And if we go angles, degrees, this would be 0 degrees, this would be 90 degrees, this would be 180 degrees, and this would be 270 degrees, and we'll be doing the conversion here and that in a minute, but those are just cutting that apart. We know that that top of that circle is 180 degrees, so we can go from there. And the quadrants have from 0 to 2 pi, or pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to pi, 2 pi. So we just kind of cut that unit circle, that coordinate plane up. So there's a couple things going on here. It says 2 angles are coterminal when they have the same initial and terminal rays. So they have to share that terminal side. And that's what I was talking about before. Like 0 and 2 pi are the same. They're coterminal, pi over 6 and 13 pi over 6. They have the same terminal side. You can find coterminal angles. You can find a coterminal angle to a given angle theta by adding or subtracting 2 pi. This is your coterminal If you're in radians, we're going to be 2 pi. If we're in degrees, it's 360. So that is the main thing there. Given a single theta has infinitely many coterminal angles because we can go around a circle as many times as we want. So if I want all of them, if I want all coterminal angles, I would take pi over 6 and plus or minus 2 pi n, and that is where n is the number of complete positive or negative rotations. The book has pi over 6 plus 2 pi n, and they're just telling you n can be a positive or negative number, but we typically associate n with the number of times you do things, and we don't do things negatively times. So I like to add plus and minus to that, but it's either one is fine. Find one positive and one negative coterminal angle to 13 pi over 6. So the first thing I better do is figure out where 13 pi over 6 is. Well, if I take 13 divided by 6, I get 2 and 1/6. So that means this is one whole rotation plus another 6. So some of your assignment asks you to draw the angle. So I drew the angle or constructed the angle or modeled the angle first. So I need one positive and one negative coterminal angle to that. So remember, I can add or subtract 2 pi. So if I take 13 pi over 6 and add 2 pi to it, well, I have to get common denominators. So that 2 pi is going to be, in terms of 6, because 6 is my common denominator, is 12 pi over 6. So if I have 13 pi plus 12 pi, I have 25 pi over 6. Now, people think, well, I just have to subtract, don't I? Well, if I would take 13 pi over 6 minus the 2 pi, which we already know is 12 pi over 6, I still get pi over 6, which is a positive angle. So pi over 6 and 25 pi over 6 would both work for positive angles, but I need a negative angle, so I need to subtract it again. So I need to subtract 12 pi over 6 again, because I need to undo this little amount right here. So I need to unwind it. So that would give me negative 11 pi over 6. And that would be a negative. So I actually have a negative, and you could choose either the 25 pi over 6 or the pi over 6 to be your infinitely many. So we have negative, our theta equals negative 2 pi over 3. So I need a positive and a negative to that. So I'm going to add 2 pi, and I need a common denominator of 3 this time. So it's going to be negative pi over 3 plus 6 pi over 3, getting that common denominator. So I would have 4 pi over 3, which would be positive. And if I need a negative, then I'm going to subtract. So this would be my positive. To get a negative, I'm going to subtract. So negative 2 pi over 3 minus 6 pi over 3, which is 2 pi. So that would be negative 8 pi over 3. So in the assignment where they ask for positive, negative coterminal angles, there you are. Okay, two positive angles, alpha and beta, are complementary if they add to pi over 2 or 90 degrees, because we've known that. Supplementary, they add to pi or 180. When you hear pi, you should think 180. When you hear 180, you should think pi, and vice versa on the 90 degrees as well. I just wanted to review complementary and supplementary. We talked about them Friday a little bit. Okay, so degree measure, the second way is in degrees, which is symbol degrees. So 1 degree is 1/360th of a complete rotation. So here's an example. 30 degrees is 30 over 360, which is 1/12. 45 is 1/8, and so on and so on. So a full rotation counterclockwise corresponds to 360 degrees, half is 180, a quarter is 90, and so on. We can break it down. Because 2 pi radians corresponds to 1 complete revolution, degrees and radians are related by an equation. It is 360 equals 2 pi radians. Rad just stands for radians. And 180 degrees, if I divide both of these by 2, I would get 180 equals pi radians. So 1 degree equals pi over 180 radians. Or 1 radian equals 180 degrees over pi, and we get both of these by just doing division. This one would be 180, taking this equation, 180 degrees equals pi. We would divide both sides by 180. So 1 degree would equal pi over 180 degrees. Vice versa here, again, we have 180 degrees equals pi radians, divide both by pi. So 1 radian equals 180 over pi. Now you notice, and it's going to be on a slide in a minute, if you don't put any units with something, it is considered, there's no units here, right here, so it's implied that it's radians, and it's important that you put your degree with your degree so you don't mess those up. Converting between radians, you multiply by pi over 180. If I want to go from degrees to radians, I multiply by pi over 180 right here. If I want to go from radians to degrees, I multiply by 180 over pi. And again, you don't have to put the rad there. You don't need it. So if I would take 30 degrees and I want it into radians, I'd have pi over 180. My degrees reduce out, my 0 reduces, and 3 goes into 18 6 times, so I get pi over 6. So it's just a simple math conversion like you would do in science. Let's say I want pi over 3 and I want it into degrees. I would do 180 degrees over pi. The pi's reduce. 3 goes into 180 60 times, so I get 60 degrees. So it's very basic how it works. When there are no units, like I said, it's implied that it is radians. And it's important to understand that because if I write 2 degrees, that is like this. It's 2 degrees. That's probably way more than 2 degrees. But if I have 2, that's considered 2 radian. Okay, well, 2 radian, let's put that into degrees. So that would be 2 times 180 over pi, which if I throw that into a calculator, is approximately 114.59, or so 115 degrees, which would be like over here. So there's a big difference. So make sure if it's degree, you put degree. If it's radian, you don't have to put anything. Okay, convert to radians. So I want degrees to radians. So I take pi over 180. The way to remember that is I need the degrees to reduce, so they have to be opposite. So they reduced, let's see, 5 goes into 135, goes there 27 times. 5 goes into 18, 3, so 18, 15, 36. 3 can go in there again, can't it? So 3 goes in there 9, and 3 goes in here 12. I probably should have done 9. So I get 3 and 4. Okay, so I get 3 pi over 4 because I reduced it. So 135 degrees is equal to 3 pi over 4. So 540, so pi over 180 again. Oh, this is, yeah. And you notice there's no symbol, so my degrees reduces, a 0 can reduce 54 and 18, well, 9 goes both of those, right? So this would be 6, and this would be 2. Oh, I guess I should have put 18. So 1 and 3. So all of this reduced to 1 down here, so I just get 3 pi. So 3 pi is equal to 540 degrees. So now I'm going to convert from radians to degrees. So I want my pi to reduce out, so it's going to go on the denominator. So my pi's reduce, and I'm going to have 0, 5, 1, 2 over 11. And it's going to be 1250 over 11 degrees, and you can put that in a calculator to approximate it. So now I have 5 radian. They don't have to have a pi in it. So I'm going to have 180 degrees over pi. So that's going to give me 900 over pi degrees. And I should have put parentheses on this. And again, both of them I could put in a calculator and get an approximate answer. You will need to be using the pi button, not 3.14. Application. We have arc length. Remember in that other slide I said arc length was S. So we have R, we have theta, and this right here, get a different color. This right here is my S. And the equation they give me is S equals R times theta. The big note, you need to know that theta is measured in radians, so you must be in radians to use this formula. You cannot use degrees. You must be in radians. Very important for this formula to work. So a circle has a radius of 4 inches. Find the length of the arc intercepted by the central angle of 240 degrees. So we are going to use S equals R theta, but this theta has to be in radians. So theta equals 240 times pi over 180. So my 10 and my 0 reduces, 24 and 18 both go down by 6. So I get 4 over 3. So theta is 4 pi over 3. So S equals 4 pi over 3, which is my theta, times 4. So 16 pi over 3. And do we have inches? And we will be doing a lot of exact answers. You could put that in your calculator again and get an approximation. Now, this formula I could use to solve, as long as I have 2 of the 3 pieces, I could solve for the other pieces. A sector is what we've been looking at. You've seen it a couple times. This here is a sector. This over here is also a sector. A sector is a circle, a sector of a circle is a region bounded by 2 radii of the circle and their intercepted arc. So basically it's a portion of a circle. It's a portion of a circle. A sector is a piece of pizza. A sector is a piece of pie. A sector is a Pac-Man. So there's lots of things that are sectors. An area of a sector is 1/2 r squared theta Again, theta is measured in radians. So going back to here, area is 1/2 r squared theta. So it would be 1/2 times 4 squared times 4 pi over 3. So, well, half of 4 is 2. 4 squared is 16. So 16 times 2 is 32 pi over 3 inches squared. Again, you can put it in a calculator for a decimal approximation, but we will be leaving a lot of things in exact answers. And that is your video for day 1 and day 2 of 4-1.